Okay, so we definitely want to make sure we have change left, all right? And like we talked about before, this is why we're using less than 12 because we want to have some type of change to bring back, even if it's a penny. All right, so asking if we will have change after buying 5 boxes of candy, which is X, and one combo is the same as asking if 5-1 is a solution to the inequality 2x plus 6y is less than 12. All right, and as we've been talking about, when we say it's a solution, it must make the statement true. All right, so if we plug in 5-1 into 2x plus 6y less than 12, replacing the x and the y with the 5-1, we can actually test if that solution is true. All right, so let's check it out. Here we are substituting our x value first. That is 2 times 5. Whenever there's a number next to a variable, it is multiplication. We will next substitute our y value of 1. All right, 6 times 1. Notice we're not replacing the 2 or the 6. You replace the amount of boxes and the amount of combos you are buying. All right, so if this is $2 for every box of candy, so 2 times 5. This is $6 for every combo, and if you get one, 6 times 1. All right, now what we're going to do is we're going to simplify the left side, all right, and compare the numbers on the right. All right, compare the numbers left and the right. So 2 times 5 is 10. 6 times 1 is 6. All right, we're going to put those together there. That is 16. And we ask ourselves, is 16 less than 12? That's no. All right, that is an automatic no. You know 16 is less than 12. So that tells you the 0.51 is not a part of the solution set. All right, so we plug it in. If it's not true, then that means it is not a solution.